Hello again. Okay, let's continue with the lesson. What I will do is I will explain the solution for this exercise. We will continue learning new functions about this library, deploy library. Okay, I will share my RStudio window. This one, allow. Yes, you can see the. Right. So the exercise said create a new data frame from the survey's data that meets the following criteria. Contains only the species ID column and a new column called hint food CM, containing hint food length values converted to centimeters. The idea of these exercises is to go step by step, and you can, in that case, you can see if what you are doing is right, and you can keep doing the. Okay, so is we need to do. Well, okay, we will do that here. Surveys. Oops. Okay, is okay. That's the. So they said that we need a new. Okay, we have to create a new column. So we need to use mutate. The new column we will call hint foot underscore centimeters. That is equal hint foot length because what originally is millimeters is not including the like in the exercise, but we need to divide it by 10. Okay, so this is one part. We have now that this new column. They said that okay, what else? We want the species ID and the new column. What does? Okay, so let's do that. So we select species ID and hint food. No, we want CM. Okay, if we execute that, well, we get a lot of. Okay, we get the species ID, hint food centimeter. We get a lot of missing values. And the exercise said that we are not, we don't want that. Okay, well, but let's we can filter that here. So we can do a filter. So is.na hint foot length on the pipe. So let's execute that. Okay, so now we got we get rid of the missing values. But okay, we want now to have the exercise says that value should be less than 3 centimeters, and we can do another filter here once that we have the new column. What we do filter, that is hint foot cm should be less than 3. Oops. Pipe. And if I execute that, okay, now I get the species ID, hint foot centimeters, Let me check if that matches what you get. Yes. So that's the so this is like the yeah, this is another solution, but it's in case that we want to use centimeters rather than millimeters, we need to like do in this way. But you are right. We can say okay, 30 millimeters and include here the yeah, you can also the okay, because also this we need to be a little bit careful with the order, because when you do the okay, first we have a surveys that is the whole data frame, and when we do the filtering in this step, the data frame that is received here is much smaller. So for example, if we do the both filters here at the beginning, the data frame that mutate receives is much smaller. So the function will be much more efficient. So also is good if we okay, for this case, R is efficient enough. But in case that we are working with large data sets, we need to bear in mind that to order this in order to get a better performance. But yes, I mean, this is not like as we have seen before, this is not the only solution. We can do this in many other ways. But yeah, that's good that you came up with different approaches. Okay, so yes, if you have any other questions, please feel free to let me know. If not, I will continue with the new function. Now we will learn about summarize. That this is now we will see there is like a paradigm that is called split, apply, combine. That is, you have data, you split the data into groups, you apply some analysis to each group, and then you combine the results. And this is to get some, okay, we have the surveys data frame. We want to get the answer to some questions that we may have. So, for instance, well, with the summarize, um, we needed to we will use another function that is called group by. Uh, well, let's start with this with an example. The example is the following. Okay, we will use surveys. Well, okay, I will write this better here because I guess it's easier. Surveys. Let's pipe. I will group by sex. Normally in group by is when you have a categorical data, when you have factors. So for example, in this case, sex, we have a female, male. Okay, pipe. We will have the average weight group by sex. So let's do that. So we need to do a summarize. Like you can use like the spelling could be American uh, or British, so you can use with as summarize. uh, or user set. If I mean, you can both of them are the same. So I want to create a new column called mean weight. Well, column, yeah, new result. That will be the mean of weight, and also well, we'll get rid of the .rm true. So if we execute that, we get a table that says that we have the average weight, the mean weight for females is 42, for males is 43, and well, for because also we have in this column that we have some missing data in the sex column. We have that the mean weight is that one. Also, we can group by for more. We can use more species. We can use, for instance, species ID, and we can group by two columns. If I execute that, I get. Well, I don't get like the whole. So first I group by sex and then by species ID. So for this female and this species ID, the mean weight is this. For this is this. So I can have different tables or different yes tables that we can use them uh, for a paper if we want to publish these tables or for plotting. Can play with the group by and summarize. If also we can do another pipe and print the tail of. If we do that, we see that well, we see that here, for instance, we have the average weight. We have we get that is not we get this that is not a number. But this is because uh, okay, because yeah, we are using there are some uh, contains in a way to remove this is to do the beginning, do a filtering because okay, we do the filtering here, but if we do filter, we filter the and now we can get rid of this. Let's see if that works. Oops. Because I forgot to put here the pipe. Now it works. So here I use a tail, but also I can use a print, I can use a head. And also I can I can sort the table. Well, okay, I will print the first 15 results. No, sorry. So I get here the first. Okay, we'll make this smaller. And you see that the results are not sorted, but I can, if I do arrange, and I use for arrange the mean weight. Don't forget the pipe, okay, so you have something similar to, okay, this is the whole query. If I execute that, I get this sort by mean weight 6, 7.36, etc. Also, it's possible to, well, here is a sort in ascent way, but we can do the other way around. If we introduce here the ascent, something like this, and we get the yes from the other way around. Minus mean. Mm, what do you mean? Like the minus mean weight? Oh, you mean to introduce here a minus? Let's see. Oh, okay, I know what you mean. That okay, yeah, it's another way. If you do yeah, minus gets the okay. I didn't, yeah, I didn't. It's like a yeah, another way of having that in a decent way. Yeah, thanks. Um, to finish a little bit with that part, also we can count we can use that is another function that is called a count, that we have a surveys pipe, and we can do a count by sex. If we execute that, we get the count on this data frame. We have that the number of female is 50, a little bit more than 15,000. For male is a little bit more than 17,000. And there are well, more than 1,000 values that are missing. Also, here you can introduce there is a parameter that is called short equal true. If you execute that, it's short by the you can sort the count. And also you can use you can use sex and species, for instance. You get the count for each male Meriami. You get almost 6,000. For female Meriami, you get this number. Okay, so let's do Mm, okay, let's do an exercise. So, okay, let's do this exercise. I will copy and paste here. So use group by and summarize. You need to find the minimum and maximum hintful length for each species using a species ID, and also the number of observations. So please let me know when you are done with the exercise and we can continue. Yeah, also I paste another exercise in case that you have finished the first one. What I see in the solution that there is a column that is missing, that is like the count for each for the because we have a species ID, the average, minimum, maximum, and also the count of each for each row. Yeah, the count is a little bit tricky, so we can see that when we solve the exercise together. Or you can work with the second exercise. Yeah, let's solve them together. Yes, because the what is left is we will see another feature of this library. We will save a clean version of the data, and we will see a little bit of plotting. But that yes, we'll see at the end. Okay, so let's solve the exercises. Uh, okay, so the first exercise says use a group by and summarize to find the mean, minimum, and maximum hint food length for each species, and also the number of observations. So, okay, yeah, let's start with the. So, what I needed to do, okay, I surveys pipe. I will get rid of the missing values, so I will do a filter is dot na on the in the footer length pipe. I will group by species ID. Pipe, and okay, I will summarize and get can do a mean underscore length equal mean over in the footer length. I can have a different. I can press enter and do the mean length equal minimum of in the footer. Oops. And I also want the maximum. In the footer length. Okay, so if let me make this. If I execute this, I get the species ID and I get the average, minimum, and maximum for each. But also I want the count of each. So the count, the way of getting that's new is okay, comma, and is where they give us a hint that is use this function n. So they will give you the the count for each species. So we see that for this one we have a count of 2, for this one we have a 45, and so on. So that's the one of a possible solution for this exercise. Okay, let's see the next one. Next one is what was the heaviest animal measured in each year. So return columns year, genus, species ID, and weight. Okay, so let's do that. Surveys pipe. Again, I will get rid of the data that is not the weights that are missing. Sorry, wait. Pipe again. I will group by year. Pipe. And I will do now I will do a filter. I will filter the I will get the max group by G. Okay, well, let's go step by step. Otherwise, if I do now select year, genus, species, and the weight. So, okay, all weights are, we don't have a missing values. And we get for the year, we get this year, for example, 1978, we get that the genus, the species, and the weight. But they want is what they want is the maximum weight. So what I can do is I can do a filter. Here, I can filter and say that the weight should be the max weight. So if I do that, oops, I forgot the pipe. Okay. You see here I'm doing uh, but it's explaining if you see in the error there is a problem with filter. Also they tell you an advice that that usually means that you have used assignation rather than the comparison. So let's okay, let's fix the error. Hit again, and now you get for each year the maximum the species with the maximum weight. You see that the years are not sorted. If you want to sort years, you can do pipe again and now arrange year. And now you get 77 we have this, 78 we have this. Okay, so that's the, have any questions? Okay, if not, let's continue with the last part. Uh, the last part I will go well quick. I will not stop a lot on this. The last part, what it explains is when we have, for instance, one of these tables, we can use the function that is called spread. So we can have we can create a different table. So we'll see an example. I will copy from the document. Okay, we have this table, for instance. I will execute that. I will make this a little bit bigger. We have that table, for instance. We have a surveys, we have got rid of the weight, we group by plot ID and genus, and we get the average weight. So we have a plot ID, genus, and the mean weight. And what I want is to do the following. I will share because I think it's better if you see the files. Okay, so the function that we will see now is called spread. So this one, and we get the plot ID, we get genus, and we get the mean weight. And what we want is we want to create this new table. We want to spread, and we will get for each genus, we will get a new column, and we will use the values of each. So we get plot ID 1, 2, 3. We get the different genus here as columns, and the mean weight is here, is the content of the table. So the function is called spread. So you use a key, that is a genus, that is the column with the new variable names. So you have here 3 different columns, and the value is the mean weight column for new variables. Our surveys GW is this table that we have here. So if I switch back to that, and I save, okay, let's restore. Let's save surveys GW. Mm, if we execute that, and I do the spread, is how surveys is one pipe and spread. These are the key will be a genus, and the value will be the mean weight. So if I execute that, I get the following table. I get for each plot ID, we get also these columns for each genus, and we get the mean, the average. So this is also a way to present, rather than presenting this table, you can use this other format. And also it's possible to do the other way around. That I will show you that is the function that is called spread, And also there is another function that is called a gather. So you see that if we have this table, we can do the other way around. We have a gather, that is the keys genus. Well, let me, okay now. Key genus, value the mean weight. Well, you need to specify that don't use the plot ID column. And you have this, this is the to use gather. So this is just to let you know that you have these two functions in case that you want to create different tables with the data that we already got. So we have a spread, and gather. And to finish this part, what we will do, okay, we'll switch back to our studio. Let's see, yeah, okay, it works. What we will do is we will once that okay, we have a play with the data, but for example, we will filter, clean some missing values, and save a clean version of this data. So how can we do that? What we will do is we will create a variable that is called surveys complete, for instance, that this variable, what it will contain, oops, is will contain surveys. Okay, I will do this better here. Pipe. For example, I will get rid of the missing the data because for the next for plotting it will be like a yeah, we don't want the missing data. So what I will do is I will do filter, and I will get rid of the weight that is missing. I will get rid of the hint footer length that is missing as well, and also there are some missing values in sex. I will get rid of them as well. So if I execute that, okay, now I have a new surveys complete that we can print it. Now we have everything is much cleaner in terms that we get rid of the missing data of weight, the hind footer length, and the sex. So you may notice that yeah, we have a less number of rows. And also, well, this is it's explained that we can imagine that we have a species that we have the measurement is less than 50 times, and we want to get rid of this. So how we can do that? Well, we can get the count for each. Okay, we have a surveys complete pipe, and we will do the count of each species ID. Filter. I will do a filter. So I want to get rid. Okay, I want to keep the ones that have been measured more than 50 times, or well, more or equal than 50 times. So if I execute this, I get table with the species ID and the number of counts. So I want to keep this species ID. So how we can filter now the table that we have? We can do surveys complete pipe, sorry, assign surveys complete pipe, and I will filter the species ID that are in a species count. Oh, I didn't save. Sorry, I should have saved that this count. Oops. Okay, let's save that. This. I will select also the column species ID. So what I'm doing is I'm getting rid of the species that have not been measured more equal or more than 50 times. So if I execute that, and now I print surveys complete, we have the total number of rows is 30,463. And I'm happy with this data set. And what I will do is I will save that data set. How can I save that? Write CSV, the data set that I want to save surveys complete. Oh, okay, I press enter before finishing it complains that I didn't specify the file. So file equal, I want to save that in another folder called data, and this will be a surveys complete.csv. So if I do that, and now I go to my files, I can see that in data, I have a new file called surveys complete. And I can use this file for the next lesson that will be plotting. So any questions so far? If not, let's see a little bit the. Okay, I see that there is a question in the chat that is repeated twice. I will have a look at that. Yeah, it's weird. I don't know why it's repeated this. Okay, let's explain the whole plotting. The thing is, the library that we will use now is ggplot2. That library contains many ways of plotting data. So what we will see here is just a little bit of how we plot data, and you can investigate further different choices that you may have to plot data. So okay, we have this. Now we will use surveys complete. So for instance, let's use. Okay, the way of plotting something is we will use the ggplot is the function. I will type this here, ggplot. And what we need to specify, we need to specify the data that we want to plot, that is surveys complete. Also, I need to specify what I want to print because what I will okay, for this sample, I will use two columns. I will use the weight and the hint food length. So the way is mapping, and I use as x is equal weight and y is equal hinder foot length. So, okay, if I execute that, we see that here in the bottom right, we have the graph that is on the y-axis. We have the hind foot length. On the x-axis, we have the weight, but we don't see any data. We don't see any data because we needed to add the graphical representation of the data. It's like 3 steps. You need what the data is as a service complete. You need a mapping that for X you will have a weight and for Y you will have the hint foot length. And now, okay, you need the what you want to print. And you want to print, well, for this example, we will use points. So if I execute that, I get a new plot here that represents for each way and hit foot length if there is a yes, a measurement of the data. Also, you can change the I mean, there are plenty of options for example, for this point, you can specify the transparency alpha equal 0.1, and you see that there is like some transparency in the points. And here you can see the what is like where you have a more weight and the relationship between the weight and the hint foot length. Also, you can change the color if you want. You can use color equal, for instance, red. Let's see if that, as you can get this in red. And also, you can do, for instance, you can use a different color depending on the species ID. So you can do the way is you type as color equal. Here we are. These are examples. I know that this is like a lot of new functions and new things to digest. But what I wanted to show here is like the power of this library in order to print functions. So we have we can use for the color a different color for each species ID. Okay, we'll make this a little bit. Sorry, so like and you see the, yeah, I think it's not okay. It's taking its time to. So you get these. You get for each species ID, you get a different color, and also you get the legend here on the right. Yeah, sorry, I'm quite okay. We'll copy that in the chat. This so what let's say the what you need to like well remember because it's what I said a lot of functions and a lot of new that we have three parts. We have data, what data we want to use. So it's a survey complete. We have how we want to map this data. In that case, we are using weight on the x-axis and input length in the y-axis, and also how we will print that. Here we are using a point that has a transparency of 0.1, and also we were using colors for each species ID. We use a different color. So that's an example of all of the many things that we could we can do. For instance, we can use a box plot that I will copy that into the chat like this here. So for instance, we can use that. We can in the X we will have a species ID and Y we will have a weight. So if I copy that and execute that, I had a different. So for each species ID, I have the weight. So I have this graphical using box plots. Also, you can add the measurements to this box plot. So I will copy that command on the on this on the chat. So if we execute that, it's taking some time to plot the. In case that we find it useful, we get like the for each species ID, we get a point if the weight is corresponds to the y-axis. So I could find, yeah. Or for example, if I don't, I see that maybe it's not, I don't like this. Maybe for example, I like this, so I can replot again and see. All of these examples are in the documentation, so you can have a look later. And also you can have a time series data. Is the time series is you can get year and genus. Okay, I will copy that into the terminal. So for instance, I have a yearly count. Survey complete, count year genus. So I have this. We'll execute that. And I can plot, for instance, I can plot this. Okay, I will explain a little bit. Is what I said. We have a. It's always like you need to remember. I know that it's like a lot of. And I'm like going a little bit on a rush. But is what you need to remember are three things: the data that you want to use. For example, in this case, we are using the data that we got, that is a yearly count. Also, we can print here if you want to see what it looks like. So what we generated is for the year 1977, for this genus, we have a 3. So for 77, for this one, we have a 222, 1, set. So we have, and we want to plot this data. So, okay, data is this one, yearly counts. How it will look like? We will use the X will be the year, the Y will be the count, and also we will use for each, because we will have a different lines, for each line we will use a different color. So you give a genus. And what I will use? I will use a line. So the geometry will be a line. And you use like this syntax, like a plus and the geom line. So if I execute that, did I copy that into the chat? No, I didn't. Sorry. I will copy that. That will be much easier. Well, here, let's see if I can replot the. Okay, see better now. We see the line of the year here on the x-axis. The y-axis we have the count, and for each genus, I have the number of measurements that they have a different colors. Also, it's explained in the documentation that you can use pipes to plot this. So a way of doing this is you can do a yearly count pipe, and you can use this. But in this case, you don't need to specify data, so you can get rid of. So you can do something like this. You print well, you give the output of this to this function, ggplot input, and just specify all of this. So you have many options that also in the documentation it's explained. You can have imagine that you want to count for year, genus, and sex, and you want to have several plots according to each genus. So you can have a facet. The way of getting that, okay, we'll copy this into the chat. So now we will use this, the yearly sex count. I will paste that in my. Another example is we will paste that. Okay, I will paste this here. So also again, well, here we have something as new. Again, we use a ggplot data. We will use what we have generated before, that is a yearly sex count. Mapping, this kind will be the X will be year, the Y will be N, and color we will use sex, and we will use the geometric style, we will use line, but in this case we will use facets. So for each genus we will have a plot. So you will see now. I think I didn't. Did I copy? No, sorry about that. Okay, so I have this, and I can, if I execute that, okay, I will make this a little bit. If I execute that, I get this. So that for each genus, I get the number of males and females along the years. So I mean, with the so that is a question that says to plot specific variables to do you mean to okay, I think I know what you mean. Here, if I mean I think the key here is to generate to filter the data. So if you want to print the first three, let's say, okay, if I print here yearly sex counts, okay, we'll make this bigger. I get all of these, but what I can do is I can filter and print just three of them. So mm, a way that okay, let's do that. I think we can. So here, what you can do is a pipe, and you can filter and say the filter will be the genus will be in, for instance. What is this in? And here you can have like a different. I will copy this one, for instance. This one. Okay, I want this one as well. I can do now again another pipe and copy and paste the figure data. And here I get rid of this. Let's see if that's not sure. So yeah, in that case, I get these three. So I get the data set. I filter because I want only these three. I want to get rid of the rest. And then the output is goes to a ggplot, and you get this. Let's see if now they're plotting. Okay, now it looks better. So for instance, okay, you are interested in these three genus, so you get that. Before finishing, I will explain how to save that. I think, well, okay, if you click here in export, yes, I will copy that, sorry. Actually, well, what I will do later in the course chat, in the Etherpad that we have shared, I will copy all of these samples in case that. Also, these samples are in the documentation, so you can. Okay, so for instance, yeah, you can do that. And last part is to save the plot. So to save the plot, you can if we are happy with this, we can save it. For example, we can use my plot. Sorry, so I save this here in this variable. Once that we are happy with the result, and the way of saving that is we need to use ggSave. ggSave, the name that we want to. Um, let's see. Okay, well, let's use my plot. Dot. We can choose the format. We can use PNG, and I can. What else I can do? Well, what I want to save. That is the variable my plot. And also I can define the width and height of this. So for the width, I will specify 15, and the height will be 10. Let's see if that. Well, okay. Let's. I will save that in the folder fig. Okay, we'll copy and paste in case that want to. It's there. So if I execute that, okay, doesn't complain. But if I go to files, go to this folder, I can see that if I click there, I'm not sure. Well, it's open in my. Okay, I will try to share. Mm, we try again, see if that works. So I get this. And we can do, for example, if we are not happy with this plot, is we say, okay, we want to make this like a smaller, or I want to change the font. I want to make the font bigger. I don't like the colors. I will use other colors. You have many ways to do that. I'm not explaining all of them now because we will need like a lot of time to go. When you need to plot something, the most probably is that yeah, you need to like search the documentation and find what is the plot that you want to do, and yeah, also see the options that you can have if you want to change the font size, color, etc. So this is just like very quick very quick explanation of this library, but it has a lot of features, and I think yeah now is well it's like 5 minutes before we finish the lesson. So please, do you have any questions? The last part of R, that is to combine R with a database with SQL. We'll see that tomorrow when we see also SQL. So please, if you have any questions, please let. I was talking all the time about the documentation. The documentation is this one. I will copy here. So there you have you can have a look at the samples, and this is like a very brief uh, part about the ggplot. If you go to the internet, you can find many others. Also, you can find the extensions. I will show you the extensions are here. I will stop sharing. Yeah, this is only like a quite a brief introduction. There are a lot of libraries, a lot of things with R. For example, these are ggplot2 extensions. I will copy the link here on the chat. So you can create all of these with R, for instance. But yes, this in like in one day it's impossible to see all of this. But yeah, you can have a look and choose and say, oh well, I would like to do this. So you see the source and you can replicate that with R. Also, if you find like a ggplot2 samples, if you search that in Google, you will find a lot of samples that you can use for your research. Okay, if there are no more questions, also tomorrow we can have a look in case that you have any questions regarding R. But yeah, I admit that now is we are very close or on to lunch time, so uh, yes, let's go for lunch. Thank you so much for attending, and yes, I see you tomorrow. We will learn a little bit more about SQL. Have a nice day. Bye.